In ASAP 2012, ASAP has added to the wide array of models available for you to simulate surface scatter within your system. In particular, we have added an ABG model as well as a K-correlation model. These models are in many ways similar to Harvey or other models that already exist in ASAP, but what this gives you is an easier way to exchange data between different pieces of software, because other optical analysis programs or other tools may provide the data in slightly different forms than ASAP has had available to you, although you could have previously been able to do these by creating your own functional definitions. So we'll take a quick look at starting with the ABG model, and I have a simple surface where I have applied a scatter model. In this particular case, scatter model 3 means the third entry in my file, which is the ABG data. And what I'm also going to do the first time we run through the program is to give you a plot of what the information looks like. So let's just click on Run. So what I have here is my scatter surface, a pencil of rays coming in, incident upon the surface, and then being scattered over in this direction. And what we see here is the distribution of energy on that surface. This is in a log scale, and this is in a linear scale. This is a representation of the measured scattered data, the BSDF plot, if you will. And this shows the data in a log-log space. And this shows the data in angle space. So what we can see is the sharply peaked distributions at several different angles of incidence. And we also can see the total integrated scatter at each of those angles of incidence. Similarly with the K-correlation, which is my fifth model, we'll also take a look at the plot of this, and I'll comment this one out for our next run. And in this particular case, what we need to do is to put in the reflectivity of the surface, the RMS roughness, the correlation length, wavelength, change in index. The 2 indicates that I have a mirror surface. And then this is the slope of my BSDF plot. Now all I'll need to do is take my sample surface and apply the appropriate scatter model. And for each incident ray, I'm simply plotting out and analyzing 1,000,000 scattered rays, and those rays will be scattered into an angular distribution as defined by the parameters of my K-correlation factors. So again, let's just run the file and we'll take a look at the results. Same scatter surface, we've just now changed the scatter profile of that associated with that surface. And in this particular case, the parameters are very similar. And here is what my K-correlation model looks like in angular space. And you'll notice that the peak intensity drops rapidly with angle of incidence. And we see that we have the little roll-off here, as is expected with K-correlation data. And again, we can look at the distribution of energy on our detector surface. So with the release of ASAP 2012, ASAP users have 2 new tools available to them to model scatter-off surfaces based upon measured or known data.